Okay, we're still on Unit 2, Day 16 Notes, Part 2. Now we have a data table. We don't have a graph. So in this data table is going to represent um, values on the graph of the derivative, and that's key, and they show that right here as well. So let's answer some questions. So number 10, on what interval is the function, the original function h of x, increasing or decreasing? Give reasons for your answers. Well, I know the original function is increasing when the derivative equals 0. That occurs between negative infinity and negative 2, not including the negative 2. And that's it. That's the only time when it's positive. Well, when it's decreasing, the original function is decreasing when h of x, h prime of x, the derivative is less than 0 or negative. So when does that occur? From negative 2 all the way to 7, not including the 7, and then from 7 to positive infinity, because we're just assuming that it's going to keep going that way. Okay? All right, number 11. At what x value does the graph of h of x have a relative minimum? Well, let's treat this like it's our sign change chart. And here's my zeros right here at negative 2 and 7. And I have positive here, negative there, and negative there. Well, I know, and number 11 says, where's a relative maximum? Well, I need to have a positive, go to a 0, and then negative. And so my relative maximum is going to occur again when the derivative changes from positive to negative, and that occurs right here at negative 2. Number 12 says, when do I have a relative minimum? What do I need for a relative minimum? I need to go from a negative to a 0 to a positive, but the only time I start with a negative value in the derivative, I go to 0, but then I continue with the negative. So we find out, and I can get rid of this, that the original function does not have a relative minimum because it has changed from a negative to a positive. All right, let's look at the next page. So if the original function h of 3 equals 2, what is the equation of the tangent line to the graph of h of x at x equals 3? So let's see what we have here. Well, the point of tangency, when x is 3, y is 2. I know that the derivative at x equals 3 is negative 3. Where do I know that from? Let's come back up here. Hey, when x is 3, y is negative 3, so that's my slope. Let's come back. Oops, sorry. Right here, so now I know my point and I know my slope, so I'm going to use the, to find the equation of the tangent line, point slope form, y minus 2 equals negative 3 times x minus 3, and then they say what is the equation of the normal line? It's still going to be at the same point, it's just where my slope of the tangent line was negative 3, the slope of the normal line is going to be the negative reciprocal, which is positive 1/3. Okay, next we're getting into some approximation. So find the tangent line approximation. So I take my equation that I have for the tangent line, every place I see an x, I'm going to put in 3.1. Let's go and simplify it, and I end up getting 1.7. So h of 3.1 is roughly equal to 1.7. So now on number 15, find the value of each of the following limits. Well, you quickly look at it and like, wait, how do I know what's going on there? Well, here's what my graph is, and I just said it was increasing, increasing, and then it got to a point where there was a maximum, and then it was decreasing. It flattened out, didn't go back up, but then it kept decreasing. So now if I look at my end behavior, as I approach negative infinity, the limit's going to approach negative infinity, and here as I approach positive infinity, the limit's going to approach negative infinity. So this, I'm getting this from the data table and from my sign change chart. Um, I'm able to see what the tails are doing. Okay, that'll be the end of part 2. Let's go on to part 3.